I'm Todd Easton, a University Distinguished Teaching Professor here at Kansas State University, and today I'm talking about lecture-based tutoring. And the purpose of this is to provide an example so that other faculty can implement this in their own teaching classroom. And besides that, I'll provide some hints and guidelines to make this lecture-based tutoring successful. And in doing this, I'm going to talk about the Simplex Method, which solves linear programs. The Simplex Method was invented by George Danzig in the 1940s, and he happened to be actually a fabulous teacher. And as you look at the Simplex Method, it gets broken down into 4 steps. First, you obtain the solution. This is done by finding the identity matrix. An identity matrix is like this. It's a matrix with a bunch of 1s down the diagonal and 0s around it. Okay? Now we'll move it around, but that's basically what you're looking for a structure. Once you found the identity matrix, the values for those variables are on the right-hand side. Okay? Everything else that is not part of that identity matrix has a value of 0, and they're called the non-basic variables. Once you have that, the next step is to find the most improving column. This will be the most negative element in the objective row. Okay? The third step is to do what's called the ratio test. And in the ratio test, we'll take that most improving column and we'll take the right-hand side and divide it by that. Now there's a special rule that if you divide by 0 or a negative number, that it becomes infinity. And once you get there, you perform a pivot, which is to try and make a new identity column by making a 1s and 0s in that column. Okay? And those 4 steps, that's the Simplex Method. So to demonstrate this, we'll go through an example. So here's a linear program. Maximize z equals 2x1 plus 3x2. Subject to negative x1 plus x2 plus x3 equals 6, 3x1 minus x2 plus x4 equals 4, and all the variables have to be greater than or equal to 0. When you remove all the variables, you get what's known as a tableau, which is this part down here. Okay, and if you look at this first one, it'd be what? Z minus 2x1 minus 3x2 equals 0. If you just minus those over, you get that equations. And so it's basically just the equations. So the first step is to find a solution. Jasmine, what is the current solution?
That's 0, right?
Okay, no. When you're looking for the current solution, you're supposed to be looking for the identity matrix. In this tableau down here, do you see the identity matrix? Or columns that could be joined together to create an identity matrix?
Would that be z?
Yep, z would be 1. And what's the one for the other ones?
X3.
Okay.
And x4.
Good. And what values would those variables have?
Z would be 0, right?
Right. You take the z here, you come across, you get right-hand side of 0. You take x3, then you're getting 6, and x4, you're getting 4, and that becomes your current solution. Okay? The next step, Leif, we are looking for the most improving column.
So is that in Z or?
So if you go back and remember that, and I know it's gone, it was supposed to be the most negative element of the objective row.
So that's -3, so x2.
So it'd be -3. So x2, that's going to be our most improving column. Okay, Brian, what do we do next? We do what's called the ratio test. Do you remember what you do with the ratio test?
I do not.
Okay, you take the right-hand side, except for the objective row, and you divide it by the column you just selected. Okay. So what'd you get for this row then?
So -1.
So you're taking the right-hand side, 6, and dividing by the
1.
1, so you get 6. Okay, and you take the 4 and divide it by?
So -4.
-4. So there's actually a special rule with the ratio test. If you divide by 0 or a negative number, do you remember what you get?
Infinity.
Infinity. Okay. And are you supposed to take the min or the max?
I don't know.
50-50 odds. Take a guess.
I'm going to go with max.
It's actually the min. Okay. It's a good guess. 50-50 odds. Okay. So that would then select our row. Everybody good with that? We've got a column. We've now got a row. Okay. So we now want to perform a pivot. Sophia, how do you do a pivot? What's the goal of the pivot?
To get the answer?
Eventually we'll get there, but we want to make this into one of those identity columns. So we want to make this element a 1. It's already there, which is exciting. And we want to make this element a 0 and this element a 0 using elementary row operations. So how can we make this element a 0?
By adding 1.
By adding this column to here. Everybody good with that? I take this column, I add down, I get a 2, I get a 0, I get a 1, and I go down like this and a 10 over here on the right-hand side. How would I get a 0 in the 1 on the objective row?
Adding 3.
Good. So I'm going to multiply this row. You always multiply this row. I multiply this row by 3 and add up. Everybody good with that? So mathematically, it's written as row 1 equals row 1 plus 3 row 1. If you do that, you get that. And there's the second one for the bottom one. You do that, and that becomes your new tableau. And we've now finished a iteration of the simplex method. Zach, what's the new solution?
New solution of this one is z and x4 and x2.
Good. Z, x2, and x4 identified by the identity matrix. And what are their values?
18, 6, and 10.
18 for Z, 6 for 2, and 10 for x4. Very good. Kayla, what's next?
I have no idea.
Okay, so we just got a next solution. I think Leif did it last time. What'd you do, Leif? What were you looking for?
Most improving, so
Most improving column. Okay, Kayla? So how do we find the most improving column?
Would it be x1?
It would be x1. Why?
Because it's -5.
Because it's negative. It's the most negative in the top row. Okay, so that gets our column. Bryce, what's next?
I can't remember.
Fair enough. This was the ratio test. Okay, so in the ratio test, we're taking the right-hand side and we're dividing by x1. Okay, so 6 divided by -1, what'd you get?
-6.
It's not -6. What is it?
Infinity.
Infinity. Okay, and the other one?
5.
5. Which one do you take?
The min.
The min. Okay, so that now gives us a row. Kathy, what do we do next?
Perform a pivot.
Okay, how do we perform a pivot?
You make row 1 and row 2 have zeros.
Okay, we need zeros there, and what else do we need?
A 1 in row 3.
A 1 in there. We're going to get the 1 first. How would you get the 1?
Divide row 3 by 2.
Okay, so the first step is to divide row 3 by 2. Okay, and that gets us that. Okay, how do we make the 0 in this one right up top?
Row 1 plus 5, row 3.
Okay, so you multiply this row by 5, add up, you get that, and how do you make the 0 here?
Row 2 plus row 3.
Row 2 plus row 3, and that gets that. Lindsay, what's the current solution?
So you have z, x1, x2.
Okay.
It's 43, 11, and 5.
Okay, is x1 11 or is x1 5?
X1 is 11.
Okay, you want to make sure you track across.
Just kidding.
Okay, because the ones here, you want to pick up the 5 on the right-hand side. Okay, so we're looking at 11 for x2, 5 for x1, and x3 and x4. What are those?
Zeros.
Zeros. And that's our current solution. Great. Kirk, what happens next?
So we're going to find the min.
Fun. Great.
I forget the term used.
It was the most negative in the objective row. Are there any?
So there's one. Well, I guess aside from 0, 1/2 would be the lowest.
Okay, so you're just looking on the top row for the lowest, but it was the most negative.
So 0 would be.
So 0 is the smallest, but it wasn't the min. It was the most negative. Since there are no negatives, what do you think you can say?
That it's solved.
That we're done. That problem with the maximization, the best answer anybody can ever find would be this 5 for x1 and 11 for x2, and that's the best. That's the optimal solution. Okay. How do you feel about the simplex method? It's not that hard, right? Okay. Anyway, that's the simplex method. Okay. You can see with one more example how you'd really start to understand it and everything like that. Okay. Fundamentally, that's how lecture-based tutoring works. In about 10 minutes, I ask 10 different people a question. Okay. My favorite part of lecture-based tutoring is the fact that I get to identify exactly where a student is lost. And I get to lend individual attention. Okay. But the whole class gets here at the same time. So it's like I'm helping everybody at the same time. Now, I like statistics, and so fundamentally, all I'm really doing is I'm just doing an exhaustive random sampling. Okay? I just sample everybody. I assume that if the person got it right, that the rest of the class got it right. If the person didn't get it right, then I go on and I tutor them, and I'm actually helping out the whole class. And so, thus, in my classes, I only spend time on concepts that are confusing. Stuff that's easy, I just breeze right through really fast with a really short explanation. Okay? Other benefits of lecture-based tutoring is because you've now answered questions in class, you are very likely to raise your hand and ask a question because you're already talking in class anyway. And so frequently as you're going through examples, somebody raises their hand and says, I got lost, and then that becomes actually my question to the next person. Well, can you help this person answer their question? And we'll just go through class like that, okay? Obviously, faculty may be concerned about covering additional material. It's going to take so long. Actually, you're still working the same example. I got through a whole Simplex method in 10 minutes. That's really, really fast. Okay? And there's more comprehension, so you tend not to need quite as many examples. And so I can cover at least as much material, sometimes even more material, by using lecture-based tutoring in my classes. Okay? And my favorite part is that it's never, ever boring as an instructor. I can teach the same class again and again and again, and it's never the same class because I never know what the student's going to say. Sometimes it's really, really funny. And so that's by far one of my favorite parts. It's a little bit chaotic for sure, and you have to be prepared for all sorts of comments and questions and things like that, but it definitely gets you out of the same class again and again. Okay? To make this successful, there are certain type of questions you should truly avoid. Trivial questions are bad. You ask somebody, what's 3 plus 3? What are your options? If they get it right, you can't say, oh, that's really good. If they get it wrong, now you got to correct somebody on a simple addition error. Okay? So you don't want to ask any trivial questions. Okay? In a similar fashion, you don't really want any yes-no questions either. The answer is yes, and then you move on and you're like, I don't know what the person knows or anything else like that. A yes-no question is fine if it's followed up by why do you think that, things of that nature. Okay? Other questions that work well, I also teach classes with lecture-based tutoring that aren't mathematically based, that don't come off and have one answer. Opinion class, I cover ethics in our intro class. And so opinion questions work well. What do you think about this? You know, would you have made the same ethical decision? Why or why not? Why do you think these people chose unethical outcomes? Things of that nature. Obviously, any open-ended questions work out well. Things of that nature. Okay? Successful strategies. Okay? Probably the most important one is to create an expectation of failure. Okay? You will notice that the first thing I did is I never ever worked an example. It's not like I gave the theory, worked an example, and then asked you a question. You work through the very first example as students. The first question I asked, there's no clue. There never is. Suddenly, an incorrect response is actually more the norm than not. And from my personal standpoint, the time when it functions the least effective is when I ask 4 smart students in a row. They answer correctly, and I got no explanation time or anything else like that, and I got all the rest of the class completely lost. Okay? And so fundamentally, you really want there to be this expectation of, I'm lost, I have no clue. Those are all actually very, very good answers because it gives you a chance to help clarify the doubt. Okay? In trying to create that, ask some really, really, really hard questions. So Jasmine, I think we're back around to you. How do you think you'd solve a minimization problem?
Not sure.
Okay, does anybody have any ideas? Okay, we just solved a maximization. Obviously going to minimization, you may want to minimize something instead of that. Anybody got any ideas?
You'd find the max value first aside from the min value, probably.
Okay, so they're going to be on opposite ends of wherever you're looking, the space you're looking. Okay, actually instead of picking the most negative, you take the most positive. Okay, now Jasmine, you had no clue. How'd you feel about the response?
That was pretty good.
Okay, not only that, I opened it up to the whole class. Nobody had a clue. And suddenly failure on the whole class doesn't cause a problem. Everybody good with that? And so you want to create that type of atmosphere where you are giving difficult questions. Okay, I've got 2 or 3 different master's theses out of teaching this method. Does anybody have any ideas? I didn't know the answer. Somebody had a good idea. Next thing you know, we're doing a master's thesis or something like that together. And so, you know, I frequently fail in class. Does anybody have any ideas? Oh, well, I don't either. You know, I was kind of hoping you guys would help me with my research. Okay, you know, this type of an attitude helps that method go so much better. Okay, fundamentally, you don't want to have the people stand up. You don't want to call attention to them. You want to focus on more or less the tutoring aspect and trying to draw all the attention to the person teaching. Okay, and that's part of this deflecting attention away. Okay. One of my favorite things to do, though, is to ask a student how they came up with an answer. I asked somebody a really hard question, and they answered it correctly. I'll say, how did you come up with it? Now I get that student's idea, I get my idea, and now we have 2 different ideas that the students can then synthesize and try and come up with the idea themselves. Okay, and I think that helps also with explanation. Okay, fundamentally, you have to be prepared for people sleeping. They're college students. Okay, you have to be prepared for people not really paying attention. Okay? I always say I'd much rather have you sleep in my classes than not. I'll wake them up. I've gotten exceptionally good at restating the question with about 10 or 15 seconds of background so they can give a reasonable answer. Okay, but that's something that you kind of need to be prepared for, because that will certainly happen this method, because you ask everybody in the class. Okay, that's about all I have on lecture-based tutoring. I want to thank everybody who's watched this. I want to thank the students who came. Hopefully you actually learned something about the Simplex method too. Anyway, I wish all the faculty that I hope that you will try this and that you will find this method as successful as me. Thank you for your time.